All right, hello, all you young grasshoppers. Thank you for joining us today. We are going to be discussing the star life cycle. There is an accompanying note page for those who are interested to help you record the information. You don't need to print that off, but you can add, and you can also just view it and write on your screen if you want. So we're going to be discussing what is a star and how stars are born, how they live. So I'm just going to share that with you so you can see that. So a star is basically a big ball of burning gas. It's plasmal gas held together by gravity, and that gas is composed of mainly hydrogen and helium. And what makes a star different from a planet is that the star actually emits light. It is nuclear burning through nuclear fusion, whereas a planet just reflects the light. It doesn't have that, it's not a big ball of burning gas. Right, so up in this little corner here, I have, right here, I have included a picture of a cross-section of our sun. We know that our sun is a main sequence star because of its color and size, but we also know it's about halfway through its lifespan as a main sequence star, and it is becoming unstable. It's about another 4.5 billion years of being unstable, but we know it's being unstable because it's beginning to be unstable because of these two things here. So this thing is called a solar flare. And this lovely thing here, that licking out that you saw in the video, is called a solar prominence. And they're basically our indication or our indicators that prominence is an A, not an E, prominence, that is our stars becoming unstable. Okay, so with the star life cycle, it's kind of, it's cyclical, and a lot of things that we're going to be learning about in astronomy are cyclical, but there is still overall change. So it's kind of like the wheels on a car. They go round and round, very cyclical, but the car is still kind of moving forward. There's still change over time, and that's something that's very important to keep in mind. So even though the star life cycle is cyclical, there is still change over time, and even though parts of it go round and round, it's still, the stars don't always look the same afterwards. So I'm going to start right up here with this, because that's where the video started as well. It's a nebula. One nebula is a nebula. Multiple nebula are nebulae with an E on the end, and that was a pet peeve of mine on that video. Although it gives me chills just to watch it, it was calling plural nebula instead of nebulae. But anyway, so the nebula is a big ball of debris and stuff left over from a previous explosion. There's lots of gas and debris, and it all starts to condense because gravity is basically the attraction between two objects, and there's multiple objects there, and they're all attracted to each other. So over time, because of the universe kind of moving a certain way, and because they're all, these little particles are all attracted to one another, it starts to condense, and it starts to condense into a star. So it condenses. Ooh, my writing has not improved on this, so we're just going to go with that. And the first thing it condenses into is a main sequence. This is step 2, not 2 of them. It's a main sequence star. Okay, so this is a main sequence star. So that's step 2. That's why there's a 2 in a circle there. It's not that it makes 2 stars. And that's where our sun is. So you notice in the diagram that looks very similar to what our sun kind of looks like. All right. After a while, it uses up its fuel and it starts to swell. So uses up fuel. And that's an and symbol, and swells. And once it swells, it grows into this massive thing called a red giant. Okay, And they get so big that they usually consume all the planets that are orbiting around them up close. So when our sun finally just uses up all its fuel and swells, it will actually consume Earth. So we won't have to deal with the non-explosion of our sun or the death of our star. We're already going to be burnt to a lovely little crisp. I know. Very, very positive topics here. Okay, so what happens after the red giant stage really depends on what size the main sequence star was. So our main sequence star, we call it 1 solar unit. So we base all other stars off of how they compare in size to our sun. So our sun, our star, is 1 solar mass unit, SMU. All right, everything else, again, is compared to our star's size. And again, our star is the sun. So if it's less than 5 solar mass units, SMUs, it's going to go down this lovely road to a white dwarf, and then eventually everything burns out and it becomes a black dwarf, which is also a dead star, because it's basically not doing anything. It's like a husk. All right, so it doesn't really explode from the red giant stage. The red giant kind of like implodes, and then it just kind of fizzles out and dies. And so that's what happens with that. All right, so that's for everything 5 solar mass units and less. If it's above 5 solar mass units, it's going to go to this other stage. So if it's above 5 solar mass units, it's going to have a mighty big explosion. And we call that a supernova. Okay. Big boom. And this big boom will result in 2 things happening. And again, it once again tracks back to the size of how big exactly was this main sequence star. Okay, so where it goes after this big explosion, it depends again on the size of the star. If it's 5 to 20 solar mass units, it will become something called a neutron star. Okay, 1 second, sweetheart. I'm drawing some notes. 1 second. Right? If it's 20 or more than 20, so 20 plus solar mass units, the explosion's so big that the recoil on it comes in on itself. So and it becomes, you did very good job. It becomes a black hole. Sorry, I'm refusing to stop the video because this is like my 3rd attempt at it.
I can do it.
All right, so that's what happens if it's super big. The other thing that happens after the supernova is that it will either produce a neutron star or a black hole, but it also produces debris. Lots and lots of debris, which I'm going to call remnants.
I have green.
I know, I've got green now. Remnants from the supernova will condense and form a new nebula. Okay, so if this main sequence star was more than 5 solar mass units, it will explode into in a big massive supernova. That supernova will produce either a neutron star or a black hole. And regardless of which of those 2 it produces, it will also have all this extra debris. And this extra debris will condense and form a new nebula. Now, do you think that nebula is going to form a star as big as the original one? And the answer is no, because it doesn't have everything. Some of that stuff formed a neutron star or a black hole and wasn't used to form the new nebula. So if we look at just the bits of this one star going around and around, it's going to become smaller and smaller and smaller. Okay. So that concludes our star life cycle. Please let us know if you have any questions. I hope that you are all doing really well and taking care of yourselves. Have a great, fabulous day.